lesson 7-2 on Wednesday, we learned about what it meant for two figures to be similar. Similar figures are figures that are the same shape, but their corresponding sides are proportional and their corresponding angles are all congruent. We also talked about how in order to prove whether or not two figures are similar, we have to check all of those corresponding sides and all of those corresponding angles. But in today's lesson, we're going to work just on proving whether two triangles are similar or not. The focus is on triangles. When we try to prove two triangles are similar, we can get by with less information. In other words, we don't have to check every pair of sides or every pair of angles. The first postulate that proves two triangles to be similar is what's called angle-angle similarity, and that's abbreviated capital A, and then the similarity symbol. In this case, we are saying that if you have two angles in one triangle that are congruent to two angles in another triangle, then you can be sure that the two triangles are similar. You might notice that it's only abbreviated with two A's. You really don't need to know that the third angle pair is congruent, because if you know that the two pairs are, and you know that the sum of both triangles has to add up to 180 degrees, that forces the third angle pair to be congruent every time that the other two pairs are congruent. So angle-angle similarity. Again, it's abbreviated capital A, and then the similarity symbol. The second option is called side-angle-side similarity, abbreviated capital S, capital A, capital S, and then the similarity symbol. In this case, we have to know that there are two side pairs that are proportional, and then because the A is between those S's, we have to know that the included angle, the angle between those sides, is congruent to the angle between those other two sides. So in this case, I can clearly see that angle A is the included angle between the 6 and the 8. I can see that the Q is the included angle between the 9 and the 12. In other words, I have the angle pair already marked congruent. Now I need to check my side lengths. I'm going to take the smallest number over here and compare that to the smallest number there. In other words, we have 6 to 9, which of course reduces to a ratio of 2 to 3. Now I'm going to check my other pair of sides to see if I get the same ratio. I have to compare them in the same order, the left triangle to the right triangle, and 8 to 12 does reduce to 2 to 3. Because these ratios are the same, that tells me that these sides are proportional. So because we have two pairs of sides that are proportional and the included angles are congruent, then I know that these triangles are similar by side, angle, side similarity. And the third and last option for proving similar triangles is side-side-side similarity, abbreviated as SSS with the similarity symbol. In this case, we simply have to check to see if all three pairs of sides are proportional. So once again, I'm going to start with the smallest side here and the smallest side there. So I'm going to look at the ratio 5 to 7.5. If you simplify that ratio, that will simplify to 2 to 3. Now I'm going to move on to my medium side lengths, and I will compare the 6 to 9, which reduces to 2 to 3. But for side, side, side similarity, I have to check the third pair also. So I'm going to take the largest side, the 8, and compare that to the largest side, the 12. And when I reduce that, I have a ratio of 2 to 3. So once again, I'm getting the same ratio all 3 times, and that's telling me again that the sides are proportional. When you have all 3 pairs of sides proportional, then the triangles are similar by side, side, side similarity. As we move into our examples, the directions now ask us, are these pairs of triangles similar? And if so, which postulate or theorem proves it? Then give the scale factor and also write the similarity statement. Well, if you look at number 1, I can compare the side lengths pretty easily. 4 to 2 reduces to 2 to 1. 6 to 3 reduces to 2 to 1. However, the included angle between those 2 sides is the angle M, which measures 70 degrees. In the smaller triangle, the included angle is angle J, and without knowing that angle J is congruent to angle M, I cannot prove that these 2 triangles are similar. They might actually be similar, but I don't have enough proof. Therefore, I'm just going to answer by saying not necessarily similar. As I move on to question 2, this is a really unique problem. The larger triangle, EQU, is an equilateral triangle. The smaller triangle, ISO, is also an equilateral triangle. Well, that means all of these sides would be 3. All of these sides would be 2. So aren't we going to get the same ratio every single time? If I compare, let's say, EQ to IS, that's a ratio of 3 to 2. QU to SO, 3 to 2. EU to IO, 3, 2. So we definitely have congruent triangles by side, side, side similarity, which means that I'm going to need my scale factor. And it doesn't specify in the directions which order to write your scale factor. So that means we will accept either 3 to 2 or 2 to 3. And then we need the similarity statement. So let's start with triangle QEU, similar to triangle. Now, truth is, every angle in the bigger triangle is 60 degrees. Every angle in the smaller triangle is 60 degrees. It would actually be impossible to put these last 3 letters in the wrong order since every angle measures 60. Just for convenience sake, we'll say triangle SIO. Moving on to number 3. So here we don't know any angle measures, but we have side lengths. So I'm going to take the smallest one from this triangle and compare it to the smallest one over there. That gives me a ratio of 8 to 4, which reduces to 2 to 1. Moving on to the medium side lengths, I would compare the 10 to 5, which gives me a ratio of 2 to 1. And then when I compare the largest sides of the 2 triangles, I have a ratio of 13 to 6. 13 to 6 does not equal 2 to 1. Therefore, these triangles for sure are not similar, meaning there's nothing else for us to do. And finally, we move on to number 4. In this case, you can see we have a right angle in each triangle. We have a 30-degree angle in each triangle. Well, that means that we all automatically have angle-angle similarity. Since we have angle-angle similarity, we'll need to find our scale factor. And you might notice the 12 is between the angle marked 30 degrees and 90 degrees, and the 8 is between the angle marked 30 degrees and 90 degrees. That means that the 12 and the 8 are corresponding sides. I'm going to reduce that ratio down to 3 to 2. But once again, because the directions don't specify the order, we would also give credit for a scale factor of 2 to 3. And then finally, your similarity ratio, similarity statement. Let's say triangle ABC is similar to, well, triangle A is the 30-degree angle, so that has to correspond with Z. B is the right angle, which of course then corresponds with Y. And last but not least, angle C would have to correspond with angle X. Moving on to our next page. In these directions, we are told that the triangles are similar and asked to find the value of X. Then it also wants the scale factor of the larger to the smaller triangle. Well, these two triangles are similar. Technically, you have these vertical angles in here that are congruent, so they're similar by angle similarity. So therefore, to find the value of X, I'm just going to write a proportion. I'm going to compare the corresponding sides. The X corresponds to the 12, and that will have to equal the ratio 42 to 14. Then remember, to solve this, we're just going to cross multiply. So we're going to have 14 times X equal to 12 times 42. In other words, 14 times X would equal 504. And when you divide that by 14, X equals 36. It does also want us to do the scale factor, but take note that it wants the scale factor as in the order larger to smaller. When it specifies the order, you have to be sure to give it in the order listed. So scale factor, and again, I'm thinking the large compared to the small. If you go back up and look at the diagram, or you can look right here at your proportion as well, we had a ratio of 42 to 14. So my scale factor is 42 to 14, but since that's just a ratio, I'm going to reduce it and give an answer of 3 to 1. Moving on to number 6. We have similar triangles told to us in the directions, and now to find X, I'm going to write another proportion. I'm going to start with 17 over X. 17 represents the bottom of the small triangle, and X represents the bottom of the large triangle. So now, in my other ratio, I need to find corresponding sides, either the left or the right, it won't matter. So I'm going to take the 12 from the small triangle, but then be really careful. The side of the big triangle is not 8, it's actually 12 plus 8, making that a 20. So then when you cross multiply, you have 12 times X equals 17 times 20. In other words, 12X equals 340. X is going to equal 340 divided by 12, which comes out to be 28 1/3. You can also say 28.3 repeating if you'd prefer. As far as the scale factor, once again, we're going to have to do the large compared to the small. If you go back to the left side of the two triangles, the large triangle had a side of 20. The small triangle just had a side of 12. So we'll have a ratio of 20 to 12. Both of those numbers are divisible by 4, which then gives us a scale factor of 5 to 3. And then we move into a couple word problems. In this case, we have a tree that's 9 feet tall. We always assume that trees, buildings, people are standing straight up unless the directions tell us otherwise. And it's casting a 5-foot shadow. So if we make a quick triangle, this is a right triangle because we are going to assume that the tree is standing straight up. And then the shadow would appear on the ground. Now it says at the same time of day. That's important because that means that the angle at which the sun shines down and creates the shadow is the same. And that's actually what produces the similar triangles. But then we have this flagpole. The flagpole, again, we're going to assume that it's standing straight up and down, but the flagpole is casting a 12-foot shadow. I probably didn't draw that very well. This would have to be taller. But we have to find the height of that flagpole. Again, remember I said these two triangles would be similar because the angle of the sun is the same because it's happening at the same time of the day. Well, then it's just another quick proportion. Let's say we compare 9 to x and set that equal to 5 to 12. Cross multiply, we're going to have 5 times x equals 9 times 12. That's going to give us 5x equals 108, and when you divide by 5, x will equal 21.6, and we must label that in feet. And on to our last problem. In this last problem, we have Joe placing a mirror on the ground 24 feet from the base of the tree, and then he walks backwards. He walks backwards until he can see the top of the tree in the middle of the mirror. These two triangles are similar because if Joe is standing upright, we have a right angle over here. And if the tree is standing upright, we have a right angle there. So that's one pair of angles that are congruent. But then something you need to know is that when a reflection occurs, the angle at which something comes into the mirror matches the angle at which it bounces off. It's called the angle of incidence and the angle of reflection. So once again, we just have two similar triangles, and we'll set up another ratio. Let's say 5.5 compared to x equals 4 compared to 24. When we cross multiply then, 4 times x equals 5.5 times 24. That means 4x equals 132. And when you divide that by 4, x will equal 33 feet. And that finishes the lesson. You have an assignment below from page 455 to 458.